All right, hi everybody. My name is Rishim Gupta. I'm a senior program manager at Microsoft, and today we're going to talk about optimizing Hadoop for the cloud in Microsoft Azure HDInsight. So before I start, I just want to do a quick survey. How many of you have used Hadoop before? So few of you. How many of you have actually run Hive queries? Okay, maybe 5. And how many have used, so do you guys use HDInsight? Or everybody uses HDInsight here? Okay. Great. So few logistic things before we start. Actually, I have a few USB sticks. So every time someone asks me a question, I can give you a USB stick. And I also have some T-shirts. So and given the audience, I think I can give every question gets a USB stick and a T-shirt. So let's try to make it interactive. That's a question. It's a good try. So yeah. So here's what we're going to talk about. So let's start with the goal of today's talk. Why are we here, and what are we going to talk about? So we all have, I think you all have come to attend this talk to hear about Hadoop, which promises analysis of big data, right? Terabytes and petabytes at scale. However, if you have used Hadoop, you do also realize that without optimizations, Hadoop can be quite slow. And so we're here to talk about how do you make Hadoop fast, right? And I really think optimized Hadoop can be quite fast. How fast? So I'm going to show you a query which out of the box runs in about 90 minutes. And with optimization, we can bring it down to 4 minutes. And I'm going to actually take you through my journey of what I did, what steps I did, what optimizations I applied. I'll explain the optimizations as we go through each optimization and see what happened to make that latency come down. By the way, I'll explain the query I used, but the data set I've used is 1 terabyte. So all these numbers is really big data. It's 1 terabyte of data. I could have used more, but for this session, I felt like that's a good segue. OK, so essentially, we've made this, for this particular query, we made Hadoop 20 times faster. And that's what I'm going to talk about. So here's the outline of my talk. Since only 5 or 6 people have used Hadoop or Hive, I'm going to spend maybe 15 minutes giving you a brief intro on Hadoop and Hive, so everybody can at least know the basics before we move on to optimizing. So I'll talk about why Hadoop, what is Hadoop, why Hadoop. I'll talk about what Azure HDInsight is. Then we'll spend the bulk of the talk in optimizing Hadoop. And finally, I'll give you a demo. I know the demo is between this talk and the lunch, but if you guys wait for the demo, I have 1 terabyte of flight data, and we'll run some queries on it. And you can actually see how many minutes, on average, what is the delay leaving out of Chicago airport if you look at 1 terabyte of flight data. And we'll run that query. So if you guys are interested, stay till the end. And I'll also take a quiz, how many minutes before we run the query. So you might get a USB stick and a T-shirt out of it. OK, with that, let's get going. So what is Hadoop? So Hadoop is a distributed processing framework. It runs on commodity hardware, and it is optimized for big data. So I would say hundreds of gigs to terabytes to petabytes of data. It provides both high-scale storage and processing. So it uses the same distributed servers for both storage and processing. Essentially, Hadoop is optimized for semi-structured or unstructured data. So if you have a very well-formed structured data, relational databases are the way to go. But if you have raw logs, if you have JSON, if you have XML, most of that, Hadoop is perfect for that. So because it's schema agnostic. It doesn't really care what the schema is. The schema is actually applied when you're executing the query, and I'll talk about that. So that's one reason why Hadoop is great for unstructured data. The other thing is, even though Hadoop queries may be slow, I personally believe there's faster time to insight. What that means is if you run queries on a relational database, from the point it gets to raw logs to the point it gets to your data warehouse, it has to be cleaned, it has to be transformed, it has to be loaded, and all this takes a while, right? And sure, you get your answers pretty fast once it's at the data warehouse, but typically you're talking about hours to days worth of delay. With Hadoop, you're actually analyzing raw logs, right? So as soon as you get the raw logs, you can run a query. Even the query might take minutes, right? But you're still getting faster time to insight. So that's the other reason why Hadoop is great for data. Finally, Hadoop, because it runs on commodity servers, the software understands that servers can fail, right? And so it's self-healing. The software actually can handle a lot of failures. Every time data is written, it's replicated 3 times. So if one node goes down, it has 2 other copies it can go. While it's running a job, if one task fails, it can rerun the task on another node. So all this makes Hadoop pretty convenient for big data and pretty useful for big data. So these are a few use cases for Hadoop that people use. The first one is clickstream and recommendation. That's the biggest one. Almost every product these days has a lot of consumer data that they want insight out of, and they're all logs. So the typical use case scenario is you run Hadoop on these logs, and then you run some machine learning algorithm and build like a personalized recommendation engine, which you can then show targeted ads to bring back your customers. Internet of Things is another one. With the advent of Twitter, Facebook, and all these sensor devices, there's so much data coming in that you really want to react quickly on data and act quickly on the data. So an example is actually one of my colleagues, Assad, gave this example yesterday. One of our customer uses sensor data. So they have stores both in East Coast and in the West Coast. So they actually, while they're selling items on the East Coast, they upload the data to Hadoop, and they want to learn what's selling. So by the time the store opens on the West Coast, they can prioritize moving those exact products to the front of the store, because that's what's selling, right? That's what customers want. Now, that's pretty fast turnaround, right? Within 3 hours, they want to get the sales data and act on it. So that's another example of how people are using sensor data to react to things. And finally, data lake. This is a new concept where people just want to put all their data in one central location and figure out what to do with it later. And that's where Hadoop works great, because it can work with all kinds of data, relational or not. So let's talk a little bit about where Hadoop fits in your modern data warehouse. So on this side, so on your left, you have a bunch of data sources which are all relational, and you could hook it up with a relational data warehouse. This can be a box software, it can be an appliance, or in the cloud, which is then you either run as a single query model or as an ETL, and then the users interact with it using BI and analytics. So this works great for relational data, but with all the non-relational data, that's where Hadoop fits in, right? So Hadoop is a complement to relational databases that you have, so you'll probably end up using both, right? That's the key message here. For relational, you should continue using the current existing warehouse you have, and Hadoop just is another piece of your modern data warehouse. So hopefully that gives you a good overview of what Hadoop is. Now we're going to talk about what HDInsight is, and then we can talk about the optimizations. So what is HDInsight? So HDInsight is Microsoft's managed Hadoop as a service. Today, when you want to use Hadoop, you have a couple of choices. Either you go deploy Hadoop yourself, on your own data center or on the cloud. However, then you are responsible for choosing the right distribution, for deploying it, for debugging it. If something breaks down at 3 a.m., you're supposed to handle it. The other option is you just use Microsoft's managed Hadoop, where we take care of that. All you tell us is how many nodes you want. We deploy it for you. We run it for you. We're actually managing it for you. If something breaks down, you call us. It's all based on 100% open source Apache Hadoop. So if you have been using any other Hadoop product, Hadoop tools, they're all compatible with our service. It's also compatible with .NET and Java tools. So we've actually built a lot of Scope Studio connectivities, Hive Studio connectivity. So if you guys are using Visual Studio, you have a way to submit Hive queries directly to our backend. We also have an ODBC driver. It also uses the latest releases across Hadoop. So we partner with Hortonworks. Hortonworks we use their distribution to run Hadoop on our cloud. And we ship pretty fast. So you'll always have the latest version of Hadoop and Hive that you can use to run queries. We are up and running in minutes with no hardware. You have a question? I'm sorry? I can't hear you. Can you? What is 2.6? 2.6 is the Hadoop version. So Hive 14, Hadoop 2.6. Hortonworks is 2.2, but it uses Hadoop distribution 2.6. So up and running, so like I mentioned, you have no hardware to deploy. You just go to our website, and I will show it to you how you can do it, and you can go up and running in minutes. And finally, you can also run on both Windows and Linux. So right now we are having HDInsight Linux is in preview, but we do allow you to run. You can choose which operating system you want. And so we also integrated with Azure Data Factory. Until now, if you had to use Hadoop, you would have to run it 24/7, or you would have to, your data would get deleted. With Azure Data Factory, we allow you to start a cluster, run your job, and then you can delete your cluster. And when you come back the next day, your data and everything still stays. So that's a great way of actually building your own pipelines, because if you have the same kind of production jobs running every day, you don't have to run our service 24/7. And finally, all this is supported by Microsoft, right? So you get Microsoft's commitment behind the product. So that's what Azure HDInsight is. Now I'm just going to show you how our, go ahead. Right. So a couple of things. Like I said, firstly, you will have to manage it yourself, right? You still have to, if something goes wrong, something doesn't work, you still have to figure it out yourself. That's number one. Number two, we have a whole bunch of tools and suites of tools for our service. So management tools, right? ODBC driver is one. You're basically on your own if you go that route, if you'd like to, but this is, I feel, a much better way, because we're giving you a managed solution. So I have not given USB stick, sorry, there were two questions. So either you guys can take it now, or you can pick it up on your way back. So, okay, so let me show you right now what our service looks like. So if you just go to the Azure Management Portal, and actually have it open. Once I log in, I'm sure you guys have seen the Azure Management Portal. On the left is HDInsight. I can choose my cluster. And this is, so let me show you how you can create a new cluster. On the bottom left, I have a new button. I can just say HDInsight, click on Custom Create, and I can give it any name. So let me say Ignite Demo. So that's the name of my cluster. I choose the cluster type, HBase, Hadoop, or Storm. I can choose the operating system, Windows or Linux. And then I can choose different versions. So someone asked me, Hadoop 2.6 is HDP 2.2. That's the Hortonworks number is 2.2, which maps to Hadoop version 2.6. So you can choose that. Once I hit next, you can actually choose the data nodes. So you can go from 4 to hundreds of data nodes, right? So if I want to go crazy, I know I have an insanely large job. I can just choose, I don't know, let me just pick 60. So I have 60 nodes. That's all you need to do, and we take care of deploying it for you. You can choose the region. And you can see we're all over the world, depending on where you're hosting your websites, Azure websites. So depending, you can choose the different. There are head nodes and data nodes. Head nodes is where all the management is done. So you can think of that's where head nodes takes care of all the overhead of running the jobs. The actual worker nodes are data nodes. So when you say 60 data nodes, you're actually asking for 60 VMs from the data nodes, and you can choose what kind of data nodes you want. Again, from A series to D series. So depending on the number of cores in memory, you can pick the right machine VM for you. And you keep going. You can hit next and submit. Within a few minutes, this cluster will be up and running, and you can run jobs. Go ahead. Yeah, so I don't think that's there in Hadoop today. That's left to the user. That's part of the things we're going to talk about, is how you do that. But today, there is no way to do that in the Hadoop community. So machine type, it's basically you have to do a lot of iteration. You have to know Hadoop to choose the right VM. So that's a separate, that's a 1-hour conversation we can take on the side. But to answer your question in short, There is no way to do that today. So if you have a 1 terabyte data set that you want to crunch, I would not pick a 4-node cluster. I would pick maybe 16 or a 32-node cluster. Part of this comes with experience. Yeah, but a lot of this depends on your latency. Are you willing to wait a day? What your budget is? So there's a lot of different things that come into picture. The more machines you want or the higher VM you want, the more expensive it will be, right? So it's hard. It's a hard problem to solve, and a lot of people ask that question. So it's a good question, but we don't have an answer yet. Can you speak louder? So the blob storage has to be in the same region as where your Hadoop cluster is running. And when you actually create the cluster, it gives you an option to hook up the blob storage with it.
Can you believe, let's say you have a 1 terabyte of data storage?
Uh-huh. Yes. I have to have 1 terabyte in Azure blob storage. That's correct. Did I answer your question? Okay.
Is there any way to kind of set a cost limit? Because, I might get eyes too big for my stomach and say, okay, I've got this thing, 60 nodes, a terabyte here, and I run out of money.
Yeah, so I don't want to make this a pricing conversation just because it's a more technical. I definitely will answer your question, but if you have pricing questions, let's take it offline.
I could ask a question inadvertently filling in the blanks, right. And then I just spent $1 million.
Yeah, so that's why a couple of things we can do. One, firstly, we have what we call Azure Data Factory, which allows you to start your cluster, run your job, and then you can delete your cluster, right? So I highly recommend that's the option you should take because then you will never have that problem. So that's the answer to your question. So yeah, that's right. So there is actually, let me show that to you. Let me click on a cluster I already have. This is a cluster I'm going to show you. There is a scale button, and this is a 32-node cluster. You can dynamically go up or down after you've created it. Right? So, okay, should we move on? So this is just to show you what HDInsight is. Now let's talk about the different technologies in HDInsight. So let's start at the bottom. So this is a typical, this is the architecture of Azure HDInsight. At the bottom, we have the HDFS storage, which is the Hadoop distribution file storage. In a usual, someone asked this question about IaaS again. This is another great thing about HDInsight. In our distribution, we have mapped the HDFS storage to Azure Blob Storage. Why we've done it is because HDFS storage is temporal storage. Unless you're running your cluster 24/7, like you were asking, which would cost you, because you have to keep paying whether you use the service or not. The moment you delete the cluster, the HDFS storage, all the files there will be deleted. Right, because the cluster doesn't exist. However, that's not very feasible for our customers. So we've actually mapped HDFS to Windows Azure Blob, which is persistent. Right? So what this means is you can, every time you're creating files or partitions or what have you, it's actually stored in Azure Blob. You can delete your cluster, bring it back again next day. But because your blob store is persistent, it can still be read. So that's one of the enhancements we've done to this stack and made it better for our customers. So that's one. On top of the HDFS storage, we have the Yarn data operating system, which enables you to run multiple engines. So there's a MapReduce engine, the traditional MapReduce engine. There's a Tez engine. I'm going to talk about Tez in the next few slides. And there's a real-time engine. MapReduce engine allows you to run Java MapReduce jobs. If you know SQL, you can run Hive jobs on either MapReduce or on Tez. And we also provide streaming jobs like Storm, and you can run high transaction using a NoSQL database called HBase. So these are a few technologies that we give you as part of HDInsight, and that comes out of the box and you get support for. So I'm going to quickly talk about MapReduce. I have a couple more slides before we get into the optimizations. So my first slide I'm going to talk about is MapReduce, because these concepts are important as we get into the optimization section. So what is MapReduce? Actually, before we get here, let's take a step back. So far, we've talked about Hadoop. We've talked about Hadoop on the cloud, which is HDInsight. And now we are talking about the MapReduce engine. Right? So what is MapReduce? MapReduce is a programming framework which allows you to run analysis on data that's in HDFS or an Azure Blob Store in HDInsight's case. Right? It consists of two user-supplied functions, a mapper and a reducer. What is a mapper? A mapper allows you to subdivide your job and then run and conquer it. And the reducer allows you to combine the result from the mappers and create the final output. So here's an example. On the right, we have a mapper where you take a large problem and divide it into sub-problems. And then you perform the same action on all these sub-problems. And then the reducer joins it and creates an output. Let's take a very simple example so you guys understand this better. If you want to select, you have a file, text file, and you want to count the top 10 words that occur the most, right? How would you do it? How would you do in MapReduce? A mapper would actually break that file into multiple parts. For each part, it would read the words and calculate within that part of the file how many words occurred, right? And each mapper would do it for its part. And then it would just give the top 10, each mapper would give the top 10 counts to the reducer. The reducer would finally look at the top 10 across all the parts and get the final top 10 most occurring words and store it in the output. So that's a simple example of how map and reduce works. So at this point of time, stepping back, we've talked about Hadoop, we've talked about the HDInsight architecture, we've talked about MapReduce engine. I'm going to end with SQL and Hive before we get into the optimization. So, and this whole presentation is mostly focused on Hive. So let's talk about what Hive is. So Hive is SQL for Hadoop. The reason it was created was it's quite hard to write a MapReduce job, right? Even to write a simple word count, it's like 100 lines. So there's a steep learning curve. And so one of the reasons why Hadoop took off was mostly because Hive came out, right? So one of the reasons in Facebook especially, where Hadoop was used primarily a lot in the early days, people didn't know how to write MapReduce jobs. Like I said, there was a steep learning curve, so people had to learn how to write MapReduce jobs. But people knew SQL, right? So they actually built this language, open source language called Hive, which is essentially SQL. So, and the great thing about SQL is if you know SQL, you know Hive, and it can scale up to petabytes of data. So these are the few properties of Hive. Number one, it's easier than MapReduce. So you don't have to write your own MapReduce. You just write a SQL job. I'll actually show you how easy it is. Number two, it's schema on read. What this means is when you're creating a table over a data set, you don't have to worry about what the schema looks like until you actually run it. So the same data, if it has 3 columns, it can be represented by different tables. In one table, it can be 3 columns because it's comma separated. The other table can just say, hey, all 3 columns are just one row, right? And you can perform different operations on it. This is very powerful, right? Number 3, it does support user code. So all the code that you have in MapReduce, you can still do that. You can actually write Python code and extend it with Hive. And finally, Hive supports multiple formats. You can do text, you can do Avro, ORC, and Parquet. And I'll talk about a few of these. So this is the Hive architecture. Hive sits on top of Hadoop. You interact with Hive by using a bunch of tools. You can use a ODBC or JDBC. You can use a query console, which is a web UI version of submitting your jobs. We have a Visual Studio connector. You can use command line interface. Once you submit your job, it is then compiled, optimized, and executed. The Hive does interact with the Metastore, which has the metadata information about the tables, the databases that it needs. And it then converts all this to a MapReduce job and submits it to Hadoop. And where Hadoop then distributes it across the task nodes and runs the job. So essentially, from a user perspective, you submit a SQL query, and the job gets converted to MapReduce. It runs, and you get the answers. That's what Hive is. So Hive compiles, and Hadoop executes. So I'm comparing relational and Hive here. You can see, as far as the structure goes, relational databases schema is on write, whereas Hive is schema on read. I kind of explained that, but in the typical relational databases, when you're creating a schema, you also have to load the table right away, right? And if the schema doesn't match, it fails. Whereas in Hive, different the schema is actually applied during execution, right? So when you're creating a table, it doesn't even matter what the schema looks like. You use SQL on both sides to access the data. Both sides support indexes. Updates were recently added in Hive, updates to tables. The key differences are, I would say, foreign keys. There's no concept of foreign keys in Hive, so that's left to the user. There is an optimizer in both cases. And finally, OLTP. So this is where Hive differs from relational. Relational databases are great for OLTP type operations like quick lookups. Hive is not really that interactive, right? So if you're looking to build web apps or like under 5-second kind of operations, Hive is probably not suited. I'm going to do a quick hello world on Hive, and then we'll jump to the optimization. So here is a cluster I created. And what I'm going to do, I'm going to go to the command line interface. So I go to the Hive folder. And I'm not showing you. OK. So I called hive.exe, which brings up the Hive command line interface. And the first command I'm doing is show tables, which is just like SQL, right? So it says these are the bunch of tables. Next, I'm going to say, OK, there is a table called Hive sample tables. I'm going to select the top 10. I did a select star from Hive sample tables limit 10. So it showed me the top 10 of this table. Finally, I'm going to do like a count star where the device platform is Windows Phone. So here's my code. So this is a good question. So I just remote desktoped into my head node. So after I create a cluster, I can remote desktop into the machine. If you remember my oldest one slide ago, I said you can use ODBC driver, you can use Visual Studio, or you can use command line interface. I'm showing you the command line interface. That's right. Yes. So the question was, how did you get here? And I was explaining that I did a remote desktop to the head node, and that's how I am running queries. But I could also use Visual Studio. I could use an ODBC driver. Other ways I could do it. So what I'm doing in this particular example, I'm looking at the Hive sample table and doing a count where my device platform contains Windows Phone, right? And so if you see, it's just like a SQL query, right? It was just SQL. And after I hit enter, what it's done is it's actually created the SQL into a MapReduce job. And it's actually running the MapReduce job. You can see the number of mappers and reducers. And it showed me the result, about 1,800 in 14 seconds. This is a very small data set, so the performance doesn't matter. All I'm showing you is you wrote SQL, it ran MapReduce. OK, so with this, I'm done. Intro, we've talked about Hadoop, HDInsight, and Hive. And now we're going to talk about the main focus of this presentation, which is performance tuning. So first question like people ask is why even optimize, right? So why is Hadoop not optimized out of the box, right? Very simple question. But I think one of the key things to realize is Hadoop is still a very early technology. Relational databases have been around for decades. Hadoop has started in mid-2000s. So there's still a lot of innovation happening, and there's still a lot of work to be done. So that's one. Secondly, Hadoop caters to a big market, right? There's a lot of people run different types of workloads. And so Hadoop's focus is to make sure a job finishes. It doesn't matter what kind of workload you run. So it's left to the user to actually focus on their workload and optimize, right? And finally, if you have used Hadoop, and if you've ever done some searching online, there are dozens, if not hundreds, of optimizations possible, right? So you all really have to know the details to figure out how to optimize your job. So we are going to talk about a few high-level optimizations today. Before that, I do want to say some key learnings that we have seen from our customers that they make. So the first thing is, so people do not really try to understand, customers don't understand their scenario, and they just look at like a few key things and focus on that, but that's the wrong way to go. For example, compression. It sounds great to have compression because you save storage space, right? However, what you forget is when you run a MapReduce or a Hive job on it, it has to be decompressed, and that will take longer. So you need to ask a question, do I want to pay the cost of actually storing uncompressed data, or do I want to pay the latency cost of actually decompressing it, right? That's the first thing. The second question, do you need to export the data? Again, you need to understand, once you've crunched terabytes of data in Hadoop, and you aggregate the data, what are you going to do with it? Are you going to bring it out? And if yes, you should think about the right format, right? You might not, if you choose ORC format, then that might not work because your tools need to be ORC compatible. The third one is the last mile problem. Who are your end customers for whom you're building your pipelines, right? If they're data scientists who are going to run Hive queries, you want to make sure that whatever format you created, like it has to be interactive, right? Your data scientists are not going to write a Hive query and wait an hour for the query to finish. However, if you use if you used ORC, that query could finish in minutes, right? So you need to understand who you're building your pipelines for. And like someone asked me earlier about what is the best cluster setup for my data set. There is no real answer, right? You have to keep iterating. The best way to do it is pick a configuration, try it. Everybody has a latency and a budget in mind, right? And you basically build a graph, right? And pick 2 or 3 permutations, combinations, and see. If it fits within your latency, great. If not, think how you can optimize more, and we're going to talk about some of these optimizations. And this is not a one-time exercise. You need to revisit this every couple of months or 6 months. And finally, plan for months to years ahead. In general, as time goes on, data keeps increasing. Your user code keeps increasing. So what works today will not work in 6 months. So make sure you understand your scenario, ask the right set of questions. And with that, you should now think about how you can go ahead and optimize. So with that, here's the benchmarking query. Here's my journey that I took, which I'm going to share with you, of optimizing. When I wanted to give this presentation, I thought I would take a query which is pretty standard. And so I chose the TPCH benchmark. I don't know if any of you have heard of it, but TPCH benchmark is a standard benchmark that all database engines use to measure their performance, right? So this is not something I came up with. There's been a lot of research done on this. So I decided to use a standard benchmark. I used 1 terabyte of data, and what this benchmark does is you can choose the different data like size. So I picked the 1 terabyte. And this particular benchmark portrays activity of a wholesale supplier. And there are a total of 22 queries. I did not run 22 queries. I picked only one, which is called TPCH1. And this query reports the amount of business billed, shipped, and returned. Particularly, this query runs 95 to 97% of rows in this table are scanned. What this means is when you run this query, it touches almost the entire 1 terabyte, right? So that's why I picked this query because it's it will really test the performance. If you are interested, this is the schema it only touches 1 table, and this is the schema of the table, which contains the order key, the part key, supplier key, discount, tax, ship date, etc. Right? Typical stuff that a retailer has. What does it look like? This is what it looks like. This is the exact query. I want to say 2 things for this query. Number 1, this is SQL, right? If you know this, if you can understand it, you can run it as SQL or Hive, right? So that's the great thing again about Hive. You can just start using it if you understand SQL. Number 2, for this particular query, it's a pretty decent query, like complex query. It has a bunch of sums. It has averages. It's doing count. There's a group by. There's an order by. So it's decently complex. So on a 1 terabyte, we're really going to test our system, right? And that's why I picked this query. OK. So at this point of time, I want to make this a little bit more interactive. So this is what I'm doing. I'm going to show you my Cloud Explorer. Cloud Explorer is a tool that shows you that basically is browsing. I'm browsing my Azure Blob Store, right? And here is my raw data, line item. If I just select all this, you can see these are 1,000 items, total of 936 gigs, right? Each file is about 1 gig. So this is my raw data set that I'm going to use. So it's about 1 terabyte. And step 1, I need to create a table on this raw data set, right? So this is how I create a table. There's some nuances here. If you know SQL, most of this looks familiar, but there's some nuances which I'll talk about. The first one is create external table. The reason in Hive you say create external table is because it resides on Azure Blob Storage, right? So you're just telling Hive that it's not in my HDFS, which sits on the machines. It sits on Azure Blob Store. So that's why I said create external table. My table is actually delimited by tab. And that's what I'm specifying here. Again, and I also specified the location. Again, this is where the schema on read comes. After I entered this table, it doesn't even care whether my actual file is tab separated or comma separated. It'll just create the table because it'll apply this row format delimiter when the actual execution of the query. But until now, it doesn't care. It'll just create it. And this would probably not work in SQL. OK, so I ran this on a 16-node A3 cluster, right? And this query ran in 90 minutes. Okay, so I wasn't very happy with it. Like, 90 minutes is a long time. So I asked myself, what else can I do? So let's talk about the optimizations I did. So the first optimization that I thought of was increasing scale. What do I mean by increasing scale? So you can either, when you are thinking about increasing scale, I can scale up. If you remember, I showed you we offer 11 different VM types. So I can choose a more complex VM type, right? So a better VM type will give me more parallelism because it can run more tasks. Or it can give me, if I'm CPU bottleneck is in my CPU, higher CPU gives me more chance of running the job faster. So the first option I have is scale up. I can also do a scale out, right? So scale out means use the same VM, but use more numbers of it. So from a 16 node, I can go to a 32 node. So these are two options. I can do scale up and scale out. And again, HDInsight makes it super easy. I can just configure my cluster here when I'm creating it, or I can choose my data node size. I showed you before, but there's a slider bar I can move after my cluster is created to scale up, right? So HDInsight makes it super easy for you. So all I did was I reran the same query, and instead of a 16-node A3, I used a 32-node D13. So this A3 is a 4-core. This is an 8-core. So I doubled my core, and this is I believe it's 8 gig, and this is 56 gig. So definitely a big bump on memory. Just by doing that, I got a 56% gain in my query speed up, right? And now it's in about 40 minutes. It's still a lot. So then I asked, what else can we do? So the second thing we're going to talk about is use Thais. So what is Thais? So when Hadoop was first launched, this was the architecture. It was quite simple. You had HDFS storage. On top of that, you had the MapReduce engine, and you would run either Java or SQL Hive on MapReduce. However, as I mentioned, MapReduce was built mostly for Java apps, right? It was not really built for Hive. Hive came later. So there were a lot of things you could do to make MapReduce better. So in Hadoop 2.0, a couple of things happened. Firstly, there was a new data operating system which came between the MapReduce engine and HDFS. And while that was coming, there was a new execution engine built called Thais. And what Thais does is it actually is quite optimized for Hive. And I'm going to talk about what it does to make it faster. But the key point here is Thais is an alternate execution engine for MapReduce. And Thais makes Hive interactive, right? So you can use Hive again now in MapReduce or in Thais. But if you use it in Thais, it'll be faster. Why is Thais faster? The first reason is directed acyclic graphs. A typical MapReduce job, when it builds a job graph, it has to create a bunch of reducers. After each set of reducers, it has to create a bunch of mappers. So in case of Thais, it gets rid of those extra mappers. If this doesn't make sense, it will in a minute. I'll show you a slide for that. But the key takeaway here is Thais can build a better graph, query graph, which makes the query execution better. Number two, MapReduce writes to the disk in every stage. So every time you run a MapReduce job, it breaks it into 3 or 4 stages, and between each stage, it writes to a file. Taze gets rid of it. There are no unnecessary writes, and write is the biggest bottleneck in a Hadoop job. Thirdly, minimizes startup delays. Because there are less mappers to create, the startup delays are minimized, and there's also architecture improvements been done. Taze also reuses containers. Wherever possible, instead of killing the process and then restarting it, it just tries to reuse the same processes, which makes it faster. And finally, continuous optimization techniques. So what Taze does is it actually, usually when a query plan is built, it's usually built at compile time. However, it's only at runtime when it really knows a lot more details about the job. For example, how many rows there are for a particular partition. So what Taze can do is it can keep optimizing even at runtime, which makes Taze faster. So here is the example I gave about the directed acyclic graph. On my left is a MapReduce, is a graph generated by MapReduce. What this query is doing is it has 2 tables, T1 and T2. It's joining them and then performing an order by. Right? So you can look what MapReduce does. It creates a bunch of mappers, reducers, writes to HDFS, mappers, reducers, writes to HDFS. So there are essentially 4 jobs here. 1, 2, so there are 1, 2, 3, and 4, right? 4 jobs here, and it has to write to HDFS 3 times. Look at what Taze does. There's no HDFS writes, and all of this is 1 job, right? And this is what makes Taze faster. So I read about this, sounded great, so I thought I'd run my query on it. So all I had to do to run Taze is I just have this setting on top. Set Hive execution engine equals Taze. I run it, and I got a 70% speed up from my original. So it went from 90 minutes, I'm down to now 27 minutes. It's pretty good. I'm getting there. So I asked, what else can I do? So the third, go ahead.
So is there any reason to use MapReduce anymore, or there are still some benefit in some scenarios for MapReduce?
So our goal is to make Taze default. At this point of time, we're still evaluating if Taze is good enough in all cases. It seems to be, my opinion, 90% of the cases it will work. But for us to make it default, we have to do thorough testing. So for all practical purposes, you can just start using Taze. So I'm always comparing to the first one. But you can do the math in your head, so, right? Oh, yeah. So everything I ran is now on a bumped up hardware. Good question. 32D13. Yeah. OK. So the third optimization we're going to talk about is partitioning. If you guys know SQL partitioning, it's quite similar in Hive. So why partitioning? So Hive, by default, reads the entire table. So if you have 1,000,000 rows and you only want 10 rows out of it, Hive, by default, will read all the 1,000,000 rows and then give you just 10 rows out of it. And this is why part of the reason it's slow is because the bottleneck is always I/O, right, in big data. So what partitioning allows you to do is instead of reading all the data, it tells Hive to read only part of the data. How is it done? It's done in Hive by when you ask Hive to create a partition, it creates partitions as directories. So each partition is a directory. And partition columns are virtual columns. They're not really part of the data. So to help you understand this better, if this is my table, line item table, and it has, let's say, years from 1986 to 2006, if I partition my table based on year, what it'll do is it'll create a directory for 1986, 1987, and so on. And under each directory, it'll put all the files, data for that year. So now when I say, hey, give me, for line item table, give me all the data for the year 2005, it'll give me all the, it'll only read one directory. It doesn't have to read the entire table, right? Partition is. I would say two gotchas when it comes to partitioning. Partitioning sounds awesome, but firstly, always choose your partitioning key or a partitioning column wisely, right? Doing a partition on sex, male and female, is not a good idea because you'll only have 2 partitions. If you have like 1 billion rows and you're going to partition on state, you only have 50 states, right? And that said, even California will have a huge skew, right? Because California has the biggest population. So you always want to have, the goal should be each partition, there should be good number of partitions, and each partition should be same size. So good idea would be to maybe do a mod on a user ID, for example, like something that'll help you make it unique. And the second thing I would say is do not over-partition. Partitioning on a user ID, just the whole user ID is not a good idea, because in the extreme, you can have one row in each partition, which is bad, because now you've created like 1 million directories, and you'll just kill our head node trying to parse through it. You can partition on more than one column. OK, so moving on. This is how you can create a partition table. So if you remember, I had a staging table, which I created. I next create a partitioning table. And in my partitioning table, I call it line item part. And I partitioned by ship date. So I'm going to skip this. I'm just going to talk about dynamic partitioning. What I did was, again, just to recap, I had a staging table, which pointed to my Azure Blob Store table. I created a partition table. And then I asked Hive to create a dynamic partitioning over it. All I'm telling Hive is, hey, go fill up this partition table from the staging table and populate it dynamically. So what Hive does is it actually, going back to my Azure Blob, there is a line item underscore part. I don't know if you guys can see this. There's a line item underscore part directory. If I click on that, I can see it's created a directory for each of these dates. Did you see that? So now let's say I say, OK, give me all the data for the year 94. It'll just have to scan this directory. So it took the 1 terabyte data and repartitioned it based on my partitioning key, right? So that's the third optimization I used. This is really quite powerful because I minimized my I/O that I have to read. With that, my partitioning, I thought I would get a big speed up, but my speed up was only 3%. Can anybody answer why the speed up was so low in this particular case? I answered this before earlier, if you were paying attention. That's right. TPCH1 reads 95 to 97% of data. So it doesn't matter partitioning or not. Again, understand your scenario, right? Because that query has to read the entire data, doesn't matter whether I partition it or not. It'll be slow. So it's something to keep in mind. If I had picked a probably different TPCH query, it would have really made a difference and showed here. OK, so we're going to talk about 2 more optimizations, and then we'll do the demo. So my fourth optimization I'm going to talk about is file formats. Hive supports different file formats. It supports text, which we've seen so far. All the examples we saw were text. It's the default, and it works with more scenarios. The second is Avro, which works great with interoperability scenarios. And the third, which we recommend highly for performance, is ORC or Parquet. What is ORC? So let's focus on ORC. ORC stands for Optimized Row Columnar Format. And this is the columnar storage for Hive, right? What this allows you to do is send predicate pushdown, which is just a fancy way of saying it, is when you run a query and you say, hey, give me, assuming you have not partitioned your data, right? And you say, hey, give me all the rows where the year matches 2005. If your data is not partitioned, if you are not using ORC, what would happen is it would read the entire table, bring the data to the execution engine, and there it would filter out everything but 2005. With predicate pushdown, this is actually sent to the storage layer. And the storage layer makes sure that it only picks the right data to expose back to the engine. So ORC enables predicate pushdown. ORC also allows you column statistics. What column statistics mean is if you're just doing a max or a min on a particular column, it stores it in its metadata. So you don't even have to read the entire table. If you're just doing max of, I don't know, order ID, right? So instead of reading a billion rows, it can just store the max and the min and the sum, some basic things which most people might use on a table. It does that for you. It also creates lightweight indexes. I'm going to show this in the next slide, but what indexes it does is if in ORC your data is sorted, every 10,000 rows, it saves the start key and the end key, right? So now as it's looking through the data, it sees 10,000 rows start, it says, oh, in the next 10,000 rows, I'm looking for 2005, but it doesn't exist here. So it just skips those 10,000 rows. And so in a way, it creates indexes without really you asking it to. And finally, reducing the compression size by 75%. I'm going to show you that the 1 terabyte was compressed by ORC to 100 gigabytes, right? So it's great for storage, too. So I think this is too. I'm going to skip this slide, but you can, if you want, you can go read later. But this is how it's stored in disk. I'm just going to mention a couple of things here. One, for each column, there's a count, min, max, sum. That's how ORC saves this. So if you ever want any of this information, it's going to be there. Also, there's compression done, which it saves in its metadata. So I'm going to skip this slide, but if you can, you should use ORC. How do you use ORC? All you need to do is, again, I had a staging table, I had a partition table. I'm creating a third table called line item ORC, where I partition it and I store it as ORC, right? Once I say stored as ORC, the next step is I just load this table from my original staging table, and it loads this table into ORC. Again, I'll show you. If I just go to line item ORC, it has about 1,000 items. Select them all. It's 1,001 items. It has 172 gigs. So it compressed the 1 terabyte to like almost 200 gigs, right? So 5x compression, which is great. Not only, so sounds great in theory. I taught you all the principles. Let's see in my adventure what did it actually do to my query. So this is the query I ran. Remember, instead of giving from line item or line item partitioned, I gave line item ORC. And I'm now in single-digit minutes. So I'm now down to 5 minutes. So using ORC, I came down to 5 minutes. Question?
So when you define the external table, so at that point, it changed the storage format?
That's right.
Okay.
Yeah.
So not when first time you load. So the data is still stored in the whatever original.
When I create the table, nothing's done. That operation takes less than a second. When I actually insert into the table, that's when it does loads it and does the compression and in the right format. So yeah, this takes a while. Good question. I forgot, but it takes like tens of minutes. So again, understand your scenario. If you're willing to wait tens of minutes while you're creating the data, but you want to make it interactive for a data scientist, this is a better option. But if you cannot wait that long, this might not be it. My point is you have to pay the cost somewhere, right? This is not magic. The cost has to be paid somewhere. You have to make the trade-off. Is it better to cook the data before to make it faster, or is it better to keep it raw and let the last mile take the longest?
Were you using a 16-node A3 to deploy?
No, 32-node D13 for everything. So if you want to compare the
Optimizing, you're going to reduce the amount of time using more power.
So even if you compare to 32-node D13, I went from 40 minutes to 5 minutes, right?
You could set up with much more power for
Sure.
less time.
So my goal was not
rather
to.
than less power for 80 minutes and have a bigger expense.
I agree with you, but my goal was not to run this query as fast as I can. My goal was just to show you what you can do. If I were doing a benchmark analysis, I would probably do what you're saying. So optimization 5, which is vectorization. So what is vectorization? So vectorization was a technology which was jointly developed by Microsoft and Hortonworks. And this is an example of where we actually took the open source code, used it, enhanced it, and then gave it back to the community, right? So a couple of things with vectorization. So what vectorization does is it reduces the CPU usage for query operations like scans, aggregates, filters, and joins. And it can only be used with ORC. So if you have ORC, that's the only time you can use vectorization. So why is vectorization faster? So in a typical query, a standard query processes one row at one time. And if you're using any kind of like a serializer or deserializer, it applies this to each row. Further, there are a lot of CPU instructions that are wasted to run each row. So what vectorization does is instead of processing one row, it processes 1,024 rows together and saves a lot of extra these CPU cycles that go when you're reading just one row. So that's what vectorization is. How do you turn it on? I just turn on this flag here. which says set high vectorization execution enable true. And I run my query again. And with that, I got another 25% increase between ORC and so I dropped another minute, right? So I just showed you 5. I mean, this is like the last slide I have in terms of my optimizations. But what I wanted to show you was just with these 5 optimizations, which are quite high level, I've gone from like 90 minutes to 4 minutes. There are like dozens of optimizations more you can do, which are more advanced. And we can talk about it another time. But the point is, know your scenario, and you can, if you know your scenario, you can actually optimize it much faster than what it is out of the box. Okay, so with that, let's just summarize all the optimizations we talked about. We scaled up. We used TES, which was the execution engine. We partitioned our data. We used a columnar format, and we did vectorization, right? These were the 5 optimizations we did. So I did not check those stats. So I see some people leaving, so I will make it a fun. This was very technical and deep, but I'm going to have a little bit of fun demo right now. So let me jump there. So what I've done actually is, let me show you the data I have. So I'm going to go to my different storage account. And I have, I got this data set from FAA or somewhere. Basically, it's a 75 gig data set, which consists of for about 10 years, what the airline delays were, which airline, which airport. That's what this data set was. 75 gigs to me doesn't sound big. So what I did was I just copied it 14 times. So it's the same data 14 times to make it 1 terabyte. It's not very scientific, but it's the only open source, it's the only open data set I have to make it big. So just remember that gotcha. It's the same code 14. It's the same set files 14 times. But if I add these all up, you can see it says, I don't know if you can see, it's 1 terabyte. So my goal is to run 2 queries. The first query I'll run is I want to calculate if I have a flight back from Chicago today, and I want to see what is, on average, how much delay do planes have on average when you leave from Chicago, right? That's the question I want to answer. So what I do is I'm going to log into my cluster. Actually, this is not it. This is it, right? So you guys have seen this before. First thing I'm going to do is show tables. And I see my data is in flights. I've already created it in the org format. And I explained to you what org is, which is the row columnar format. So I'm going to run my query on org. So let me show you my query. In this particular case, I did not. OK, so this is my query. And again, I don't know if you can see it. Let me increase the font here. Is it good enough, or font 20? OK, so I'm selecting the origin airport, the average of the departure delay from this flights table. Remember, this is 1 terabyte. And I'm grouping it by the airport and ordering it by the delay. And I'm only looking at the top 50. I think, given how busy Chicago Airport is, I think it'll be in the top 5. That's my guess. So let's run it and see. OK, while it's running, anybody wants to take a guess how much? It'll take some time. So then does anybody want to take a guess? How long do you think the delay would be if you leave? Sorry?
How many nodes do you use?
So again, I'm using same 32-node D13 cluster. So I'm not asking how long it takes to run. It doesn't matter. The answer should be the same, 4-node, 32-node, 64-node. 37 minutes. OK, he thinks he'll be 37 minutes late on average. Anybody else? Sorry? 5 minutes, OK. 22 minutes. So I'm running real time. So this is actually running on that 1 terabyte data set. So far, I got 22 minutes. By the way, I want to do both. I want to look at the technology. OK, so I think I got enough guesses. We'll see what it's doing. I do want to explain what it's doing. When I ran this query, it's created a bunch of mappers and reducers. Because it's using TES, it created mappers and 2 sets of reducers. If this were a MapReduce job, you would not see this. You would see two separate jobs because it would write to HDFS in between. Right? Again, it's just showing you the power of TES and ORC. So it's almost done. Like, it has to go through 511 mappers. It's almost done here. So let's see what the answer is. So the time taken was 85 seconds. Sorry, I'll come to the question in a minute. 85 seconds, it went through the entire 1 terabyte partition. Remember, it did use ORC's, obviously, optimizations. But the key here is it did bring me all the data that I wanted. Right? And let's see where ORD is. I know ORD is right here, 12 minutes. So that's the answer. And on average, 12 minutes is the delay it takes. I did a percentile, actually, also 50th percentile to do a median, and that came out to be 1 minute. So my point is, it could be like some sites are really delayed, and that's what skews the average so high. So anyways, just to give you an idea of what, it's kind of interactive, right? With a 1 terabyte data set, it's quite fast. Someone had a question, right?
But it's 2 days for your group by sorting and all that operations, right? What if that node goes down during that is happening? So will it pick up the other node automatically?
It will. Hadoop does take care of if one node goes down, if one data node goes down, it will rerun the job in another data node. Yes. Okay. So I'm going to show you one other thing, and then we're going to talk about a customer case study, and then that's the end of my presentation. But here's another query. What this query does is I'm going to use the same data set, and this time I'm going to actually use Power BI, because what I want to show you is end-to-end how, again, because someone asked about HDInsight versus IaaS. Using HDInsight, you can use all these awesome tools that we've built. So what this query will do is it's actually looking at for the year 2005, what the total delay was, right? And I'm going to plot the total delay as the year goes by. That's my goal. So I want to see a graphical representation of the delay. So what I will do is I'll open Excel. And then in my data sources, I'll go to From Other Sources, From Data Connection Wizard. I've already created a Hive. I've installed the Hive ODBC driver, which connects to HDInsight. In my Hive ODBC driver, this is the cluster I'm using. And I have to enter my username and password. And then it takes a second here to validate my credentials, so it might freeze while it's doing that. So what this would do is, again, ODBC driver will allow Excel to send a query to HDInsight, get the data back, load it in Excel directly. So I never even have to do remote desktop or anything to my cluster. I'm just using Excel and running queries. And then I can use Power BI to play with it, visualize it. So at this point of time, it's validating my credentials with the backend. And it actually got all the tables I have, right? And if you remember, I had flights and line item for my TPCH query. I hit next, and I hit finish. And then in my properties, I'm going to just copy this query, right? So again, same query like I showed you, and I'm just going to hit OK. So it's going to ask me for my password before I submit the query. At this point of time, it submitted the query, waiting for the query to be executed. It submitted the query. This might take like a minute. I don't want to wait. I'm going to end with a customer case study. We'll go through the case study, and then we'll come back, look at the results, visualize, and then we'll open it up for questions. And I have not given out these USB sticks. I'm sorry. It's hard for me to manage. Whoever asked a question, just come on by, or whoever needs a USB stick, just come on by. I have enough to I guess, share it. OK. So we're going to talk about a customer case study. So this particular case study is pretty interesting because they use some of the techniques in our optimizations, but they also went out of the box, right? And this is just to give an example of, based on your scenario, you might have to be more innovative and think out of the box. So this is a large internet web company. Their scenario is they had a bunch of clients which were uploading data to Azure Blob Storage. And then they would use Hadoop, HDInsight, to read data from Azure Blob Storage, do a bunch of machine learning on it, put it back on Azure Blob Storage, where it would then be used in Power BI or web apps or what have you, right? So that was their scenario. This worked great for the first few months, but as their data kept increasing, they kept scaling up this HDInsight cluster. Soon they had hundreds of nodes of HDInsight running. And while that worked great, they started hitting a bottleneck. And what was that bottleneck? The bottleneck was Azure Blob, because Azure Blob Store has a throughput limit on per file and then also on your per account, right? And while that throughput is quite high, it's actually quite, I'm just saying these guys tested even the limits of what Azure Blob Store could give them. So that's when they thought, what else could they do? So this is how their partitioning strategy was before they started. This is how they actually stored their data before the problem started occurring. They had one Azure Blob Storage account, and they would partition it based on year and month, right? So everything under October 2014 was in this directory. Everything for November 2000 was in this directory. Everything in December was in this directory. So they had 3 partitions. This is how it worked. And like I said, this is where the bottleneck happened, right? Because they had a lot of reads and writes. So they came to us to discuss how we could help them. So this is a bunch of code. I don't know if you want to see that. I'm just going to skip. This is the recommendation we gave them. Instead of using one storage account, use multiple storage accounts, and also use partitioning more strategically. Right? So you guys, I explained partitioning, so hopefully that makes sense now what it is. What these guys did, instead of writing data for October 2014 in just one directory, they sharded it across multiple storage accounts. Right? They did the same for November, the same for December. And what they did was now in each partition referred to one blob storage. So going to the next slide, I think this might make it a little bit more easy in the code. In their partitioning strategy, they added an account number at the end, right? And then in their input, so let's go back here for a second. So when they ingest data in this Azure Blob Store, they had a bunch of these, right? They had 4 of these. And they would say, OK, randomize data. So one of those goes here. So for the month of October 2014, data would randomly go in one of these 4 blob stores, right? 1, 2, 3, 4. I don't have that shown. I'm sorry. I should have made a picture. But you get the point. Instead of one blob store, they had 4. And when they were ingesting it, they would randomly put it in any of the blob stores. And then they would this code would make sure that for any month, they are going to, because they've given an account number, they would run the same. This is how they added the partitioning. And then what they would do is for month of October 2014, they would go and read through all the storage accounts. And because this throughput, they had less data to read now compared to the original, because per storage account, the data is reduced by 4, their throughput increased 4 times. So using a combination of partitioning and multiple storage accounts, this is one case study that it really improved their performance. OK, so before we end it, I got my data, by the way. It took about a minute. Now let's go visualize it. The first thing I'm going to do is I'm going to go to Power Pivot, and I'm going to add it to data model. The reason I'm doing it is I want to change the date from string. So I want to change this column from text to date. After I do that, I save it, and then I go to Power Maps. So it opened Power Maps. I choose my airport location as next. I choose my flight date in my timeline. And I choose the total delay here. Okay, and then if I play it, it's actually showing me, as the year 2005 happened, how the delays are growing. You see that? And I don't know if you see, this is just showing you the total delay, but in general, Atlanta had the most delays. And Chicago was a second close. So anyways, hopefully none of your flights are delayed, but the statistics say 11 minutes, and they also say, if we were Atlanta, we'd be worse. Let me just put it that way. So that's OK. With that, I'll open it up to questions. We do have a few more sessions. We've had a few sessions already. I believe there's one more this afternoon. So If you haven't, make sure you go to those. If you want to join, if you haven't used HDInsight, you can get a free trial here. We also just we just did Azure Data Lake Preview, which makes using HDInsight much faster because, like I talked about the throughput on Azure Blob, Data Lake has very high throughput rates. So, so you should also try that preview. Any questions?
What's your views on HDInsight versus Cosmos?
So Cosmos is an internal first-party tool that we use. So HDInsight is more open source than Hadoop. So they're two completely different technologies. So I don't know about that, but right now there are two separate. Cosmos is all internal first-party that our engineers use, and HDInsight is the product we sell externally.
So a few months back when I was exploring HDInsight, it looked like it was a little bit late behind while Cottonworks does distribution and improve. And I see a lot more things. So do you know how much frequently planning to bring all these things?
So we're pretty frequent. I don't have timelines, but if there's something missing that you really need, just we're pretty, as the PM team, we're pretty active on Stack Overflow. Just reach out to us. There's many ways to reach out to us, and I would just say usually it's weeks or months. It shouldn't be longer than that. Yeah.
Does Hadoop support encryption at rest?
So I know there's a big push on security in the team. I do not have answer to that question, but if you give me your card, I can follow up offline and have one of our security PMs talk to you about that. I don't know if Nishant, do you know the answer to that question?
I didn't get that question. Can you come again?
His question was, do we support encryption at rest?
Not currently.
Yeah.
Yeah, not currently. But we're working on it actively.
Yeah.
So very soon we'll have that at the blob storage level as well.
Does it support geofencing?
Does it support?
Geofencing, geographical limitation, geographical location.
I don't. Do you know that again, Nishant?
Currently, any kind of security model that you want to implement is at a storage blob level. Anybody who has access to that storage account has access to the entire data. But yes, what we do is we definitely support geo-redundancy of the data. So if you really want to go ahead and replicate your data across geographic locations, at the storage blob level, that's automatically taken care of as an option when you create that.
What was the format of your files you sent into the Hadoop?
So, format of my files for you're talking about the optimizations. Text. It was just CSV. So you can write your own serializer, deserializer to convert the binary into something that Hive understands. But you'll have to write your own custom code to do that.
Is it in Java?
You can write Java or Python. Yeah. You had a question, right? You had a question.
Yeah. For EDW architecture, is there a plan to support SQL Server plus the Microsoft has NoSQL like document DB, right?
We have HBase and we have HBase too.
Does it get integrated with Microsoft HDInsight architecture?
So DocDB works with Azure Blob, and HDInsight writes to Azure Blob. So that's another powerful reason of why, again, IAS versus HDInsight. You get the whole goodness of the Azure products because all of them talk to Azure Blob, and they will soon talk Azure Data Lake, right?
And DocumentDB has an HDInsight connector, a Hadoop connector also. Yeah.
We are a company who have an IoT platform and we store all of that information in our devices.
Mm-hmm.
We're trying to figure out how to offload the machine data and keep it to the cloud. Are there customer who have done this? How should we do it?
Yeah, why don't we take this offline? If you have a minute, after this session, let's talk about that. Yeah.
So the last case study you showed that internet scenario customer data coming and Hadoop does processing and showing to Power BI all the way. Is it
So Hive typically is not the real-time solution. Hive is mostly for historical, like crunching data over historical. If that's what you're looking for, we had a session yesterday. I don't know if you attended the talk by Asad and Nishant. So Stock is probably a better choice for that. Yeah.
All right, I think before Rasham lets everybody walk out, this is the first time Rasham's doing a presentation up at any of the conferences, so we'd really love to hear some feedback on Rasham's presentation. Please go back to MyIgnite, give some reviews back. We'd love to hear that. Thank you so much, everyone.
I have USB sticks here, by the way. So.